I begin to I begin to
Good day, everyone. My name is Ifeoluwa. Here we are at Fountain TV, and today is another segment of GNS121, which is Philosophy of Science, and it's going to be the episode 4 of the course, and we're going to talk about the chemistry aspect. Last time we talked about the physics aspect, the chemistry, GNS121, and under this chemistry aspect we're going to look at some basic terms in chemistry. And the first one is going to be atoms. We'll define atoms, molecules, element, compounds, and mixtures. We'll talk about the pH scale, that is the acidity, and the basic or alkalinity. We'll talk about it, and the last outline is the separating techniques. The various separating techniques that we have. And let's start from the first one, atoms. The first outline here, atoms, molecules, elements, compounds, and mixture. We're going to define them and know much more about them. Let's start from atoms. An atom is the smallest indivisible particle of a matter. Now, if I say of a matter is just is anything that has weight and occupies space. So the smallest indivisible particle, or the smallest the basic unit of that particular matter is what we call atom. And now, example of a matter is like a paper. Now, to the extent that you can divide that paper to the smallest size, and that is the atom of that paper. Now, in chemistry, when we have, like, let me say water, that is H2O. Now, these atoms come together to form this particular compound. This is a compound. Now, the smallest unit of this water is called an atom. Can we get that? So, an atom is the smallest indivisible unit of a matter. So we get that like that. Now let's go to the second one, molecules. So if you're talking about molecule is a group of atoms that are bonded together, and they cannot be separated by they can take part in a chemical reactions. A molecule. Now let me come again. A molecule is a group of atoms. That is, when we say group of atoms, that is group of smallest indivisible unit of a matter that come together, and they can actually take part in a chemical reaction. Now, when I talk about chemical reaction, that is what the combination of chemicals. Chemical reactions, something like the nuclear reactions and so on. So a molecule is a group of atoms that comes together by some chemical means, and they can take part in a chemical reaction. Now, I told you this is a particular compound. Now, we can have one molecule of water. Now, in this compound now, it's telling us that we have 2 molecules of hydrogen and 1 molecule of oxygen. Let me break it down. We have H2O. How many H do we have? We have 2 H. And we have 1 oxygen. Now, a molecule of water, out of this one, we have 2 molecules of hydrogen and 1 molecule of oxygen that will give us a particular compound. And now, in these two molecules of hydrogen, that is, we have what? Two atoms. We have two atoms that is coming together to what? To give us what? Two molecules of what? Of hydrogen. And that is that. So we have let's go to the next one. Element. What are elements? Elements are chemical substance. Elements, they are chemical substance that cannot be broken by any chemical means. They are, let me say, they are naturally occurring substances that cannot be broken by any chemical means. We have examples of elements. That's why we have the hydrogen, helium, lithium, beryllium, oxygen, fluorine, sodium, chlorine, and all that. These ones, they are naturally occurring elements. They are naturally occurring chemical substances that cannot be broken by any chemical means. And they can actually take part in a chemical reaction also. But they cannot be broken down. They cannot be splitted. Let me come again. Atom is what is the smallest indivisible particle or unit of a particular matter. Molecules is the group of what? Group of atoms coming together to what? To take part in a particular chemical reaction. And elements, they are naturally occurring chemical substances that cannot be splitted or broken by any chemical means. Well, let's look to the last one, which is compound. A compound too is a chemical substance consisting of one or more molecules. I explained that the other time using H2O. I said in this H2O you have two molecules of hydrogen and what? One molecule of oxygen. That is two different molecules coming together to give us what? Water, which is a compound. That is, this is a molecule. This is a molecule giving us what? A compound. So, denoting this, a compound is what? Is the combination of what? Of two molecules. Two or more molecules. We have a lot of compounds that are, let me say, an example is the NaHCO3. We have sodium, we have hydrogen, we have carbon, we have oxygen. Two or more molecules coming together to give us what? A compound. And that is that. So let's talk about mixture. What is a mixture? A mixture is a physical combination of two or more substances in which they retain their identity. Now, mixture is just the physical combination of two or more substances. Example is also your water and garri. It is a mixture. Your hair, the air we breathe in, it is a mixture. We have a lot of elements. We have a lot of gases in the air. We have nitrogen, we have oxygen, we have fluorine, we have phosphorus in the air. That is, they come together, they mix. And the funniest part is that in a mixture, all subsequent, let me say all gases or all molecules that are inside what? A particular mixture, they retain their identity. A garri will remain garri, even though it has been poured inside water. A water will remain water, even though it has been poured inside an ethanol. So a mixture is what? Is just a physical combination of two or more substances together. That's the definition of mixture. We have an examples of mixture. We have garri and water. We have your table salt. That is the NaCl. You can note that NaCl. That is what? Sodium. Na means sodium and Cl means chlorine. And it is named as table salt. The salt that you use to cook. That's NaCl. NaCl, table salt. So when you pour your table salt inside water, it is a solution. It is a mixture. And that is that. So let us go to the pH scale. The pH scale is very, very simple. pH scale. This is how it looks like. pH scale. We have a straight line like this. The pH scale ranges from 0 to 14. Let us note that. The first thing is that it ranges from 0 to 14. Now, how do we determine the acidity and the alkalinity? When talking about acidity, it has high content of what? Of hydrogen atoms. That's acidity. High content of what? Hydrogen atoms. So now, the middle of 0 and 14 is that's 7. 7. Now, anything that is less than 7 is what? This place is acidity, and 7 is neutral. Why? Higher than 7 is what? Is basic. That is, less than 7, anything less than 7 is what? Is acid. Equals to 7 is what? Is neutral. And greater than 7 is basic or alkaline. That is that about this pH scale. So less than 7 is acid. The 7 itself, when it is on 7, the pH scale is on 7. That is neutral, and basic is what is greater than 7. And sometimes you will take what we call that this line. When you take it, you see that it will somehow changes your what it will be somehow sour. So it has high content of what? Of base in it. It has high content of base in it. That is how it is like that. So that kind of line, it is what we can say. It is what it has the pH scale of that line. It ranges from 7 to 14. But something that is acidic, it ranges from what? 0 to 7. And why 7 itself? It is what? Neutral. And that is that. So let's talk about these various separating techniques that we know in chemistry. The various separating techniques that we know. There are a lot of separating techniques. Actually, let me just give you what separating techniques mean. It's just like a method or way by which you can separate 2 or more things. You know, we can actually separate mixture. We can separate molecules. We cannot separate elements. It cannot be split. We can separate compounds. So the various ways we can actually separate these things is called separating techniques. So I will list them down for you. The first one that we have sieving. The second one we have decantation. And the third one we have filtration. We have condensation. We have distillation. We have solidification. We have sublimation. We have fractional distillation. We have chromatography. And Mr. etc. Yeah, these are various separating techniques. Let's just take them one by one. Sieving. Sieving is just separating solids of different sizes. Now, this local food that we used to take, let me say, how do they call it? Elubo. Yes, we can see that we used to sieve them out because they are solids of different sizes. You can actually sieve out what? A sand, and sharp stones. When it is packed together, we can actually sieve them out because of what they have different sizes, and that is sieving. Now, decantation. Decantation is just that the separating of insoluble solid from liquids. An example is when you want to wash your rice. So when you are washing, when you pour water inside your rice and you are watching it, now you want to decant it. You will decant out the water, and you will leave the solid inside the container. That is decantation. Now let's talk about filtration. Filtration is just the separating of solids. Of liquids, which are immiscible. Immiscible in the sense that they are not mixed together. And filtration also can be used to separate solid from liquid also. We can actually filter out what the solid and leave what the liquid. Just like an example is all the sand and water. So you pour it inside the particular funnel. There's a funnel called filtrating funnel or a filter paper. You pour it out and you filter the water out and leaving the sand there. That is filtration. Now condensation. Condensation is what is the turning of gas to liquid. It is a means of separating something also. When you condense a gas to become liquid. An example is the evaporation of water. When you are boiling a particular water, you can see that there are some kind of gas that will be going up. In the lab, it can be collected back to liquid using through the means of condensation. Now, distillation. Distillation is just a part segment of fractional distillation, and it is used to separate miscible liquid with the same boiling point. While solidification is the turning of liquid to gas. That is your water. When you put your water inside the refrigerator for a long period of time, it will turn from liquid to solid. From liquid to solid, or from solid to liquid. Yes. Now sublimation. Sublimation is turning of from gas to solid, or from solid to gas. An example is the camphor. When you put the camphor in a particular place, it will turn to gas directly, not passing through the liquid state. That is that. And fractional distillation is a separating of fractions of some particular liquids which have different boiling points. An example is the crude oil. You can actually separate it into fractions. And in the sense that we'll be able to get the paraffin, we get the diesel, we get the kerosene, we get the petrol and gas. So they have different boiling points. So at each boiling point, each of them would drop down using fractional distillation. And chromatography is just used to separating colors. When there are mixtures of colors together, we can use chromatography to separate them. And that is that. We've covered a lot today. We talk about atoms, molecules, elements, compounds, and mixture, the pH scale, and the various separating techniques. I hope you join us next time on this YouTube channel, and please like and subscribe to this channel, and God bless you. Thank you very much.